Hello, everybody. Welcome back for day two, coding bootcamp. We're still in week one. Thank you, everybody that showed up online on time. I know most folks will trickle in as we go, and some people just watch on the recording. All good. We are going to go over algorithms, applications, and programming basics with Python. So we're going to do an intro to Python syntax today. How to use some basic parts of it, the writing rules. When I say syntax, that's generally what I'm talking about. It's not syntax in the sense of sentence structure, but it's how we write, how we spell things. And then we're going to talk about applications. We're going to end today by running very simple application in Python and hopefully give everyone a framework to start having something to play around with between now and our next time together that's directly in Python through our Bash console the way we have been. So we're going to build off what we did last time, working in Python anywhere like we have been. As a quick note, actually, about that before we go any further, if you're doing the parts that we're doing now, not in Python anywhere, that's totally fine. If you want to do it on your own terminal, on your own computer or something like that, that's totally fine. You can really do the entire course like that. The reason we do it in Python anywhere is so that it's accessible for everybody. It's something that you can get to even if you don't have your own device, but if you do that, you can do it locally if you like. When we build the application, it's going to be built directly in Python anywhere and deployed straight from there. So you can do, again, those things locally if you like, but it won't be deployed live like it would be on Python anywhere. So just throwing that out there. If any questions about that along the way, definitely ask because we'll be using that the whole time. Before we dive into what we're doing today, let's do a quick review. Even though we've only done one day, we did quite a bit. So I think, and instead of grabbing all the things we did, we're going to highlight some bits that we're going to move forward with and hit as recurring points. One of the main things we talked about was languages, right? The human and machine languages and the dichotomy between them. Thinking about how we communicate. That's the how we communicate with computers, how we write in one of those languages and the computer understands it as data was the one time we talked about it. What do we talk about data in terms of? How do we define it last time? Anybody remember?
Bytes and bits.
Bytes and bits. Yes. What are bytes and bits?
Binary,
Zero and one binary.
Okay.
binary and X and octal.
Yes. So binary, ones and zeros, and a bit is a one or a zero, and a byte is eight of them. Right. So that is the sense we've talked about data so far. Today we're going to talk about data again in the context of data types of Python, right? And well, data types generally in any programming language, but we're going to talk about the ones in Python that the Python uses. It is an arrangement of these bits and bytes. Think of it as that. So it's a way of interacting and actually building the basic parts that we'll use to make our programs and applications. And we'll go through there. So those are the main things I want to keep in mind is the dichotomy between human and machine language that we'll keep running through and the decisions that we make on readability between the two, and data that at its heart is always going to be those ones and zeros, and it boils down to that no matter what you're writing in. Any questions about any of those things? Anybody stuck anywhere else have anything before we dive into our content for today? All right, cool. So as we go, feel free again, take yourself off mute. Got a handful of slides, about 250 of them. No, there's only like a handful of them real quick, and we're going to go back into hands-on Python anywhere. So be ready to write if you can. If you just want to watch and write later, that's also fine, but try to stay up with us if you can. All right, so conceptually, let's start talking about algorithms. Algorithms was another term that we're going to use again in somewhat different context, but as a basics form, when we talk about what an algorithm is, it's just a set of instructions on how to complete a task. That's really what it's doing, right? So a great example of this that you could find in the class before, but it's very time consuming, so we'll skip it and just use the analogy, is giving directions to someone to make a jelly sandwich, right? So imagine writing down for a child how to make a jelly sandwich, or writing down to somebody who, which is, it almost always goes off the scene in anywhere else. It's pretty hilarious. The idea, though, is that a computer doesn't know anything. It doesn't know what a jelly sandwich is. You have to tell it that. You have to explain to it what picking things up and putting things down means and all of that, right? So that's what algorithms are in this sense. There are specific characteristics of an algorithm to keep in mind, right? This is not something you need to learn by heart, but keep the concept is really what we want to get to. So there's finiteness. The algorithm has to be a certain set of steps that ends at some point. It can't just run on forever. Each of those steps has to have a definite purpose and do a specific thing. They're not just steps for the sake of it. There's going to be input. Zero counts as an input. but that is part of an algorithm. There's going to be input and there will be output. So you always have input, you always have output. And then the last thing is its effectiveness. To have some purpose that it serves. There's a reason that the algorithm is doing, it's a problem that it's solving, it's doing a specific thing. The more specific you could be with the algorithm, the better. But this is the general definition and the general characteristics set for an algorithm. Any questions about this? Great. So let's slide quickly through application development, testing, and debugging, these concepts of what they are and things like that, defining generally what applications are. So it's a program, piece of software designed for a particular purpose of the user, right? Sounds a lot like an algorithm. And it's really just a collection of algorithms. So an algorithm would be like a small piece of an application. Things like Zoom. We're on Zoom right now. The purpose of the user is so that we can communicate with each other via, video. Anything that you interact with Python anywhere, that's an application. It has a set of algorithms that allow you to do certain things within it, right? This is common knowledge in modern day. I don't expect that anyone has never heard of an application before or didn't know the definition, but I want to make sure that we're level what we're talking about as we go to build our applications. The main thing to really keep in mind here as we go through this, though, is it's never going to be anything more than files in directories. I'm going to hammer that a lot. Doesn't matter how sexy the software is or how cool the application is, it's always files and directories. So you're going to be doing that today. For anybody who's never done one before, we're going to write a Hello World application to get going. It's a really standard first application to write for beginning programming, where we're basically just going to have this phrase printed out to us based on a simple set of directions that we're going to give. We're going to do that in Python. So again, these could be simple, these could be complex. This Hello World application will technically be an application, even though the purpose is benign. It doesn't really solve any cool problems. We're going to meet all the requirements to be an application. You'll be able to take that framework and build more complex stuff after today. And what you will build will be run directly from the command line interface like we have been in the Bash console. But when we go to build our web application, it's going to be the same thing. Same principles. We're just going to expand it into being launched the web browser. The same can be applied to mobile devices, desktop platforms, whatever. Applications as a concept are these things, no matter what platform they're on. And you can approach developing any of those softwares in the same way. And you pick different tool sets, like we talked about, the languages, depending on what you're trying to do. If you're doing, like, say, desktop stuff, you might choose Java over Python, but they're still doing these same things, and you're going to be following the same processes to bank your application. All right, debugging. This is a hugely fun process. So we're not going to spend a lot of time talking about it because we're going to do it along the way. As we get hands-on, stuff's going to break. I'm sure people have gotten stuck already. Getting yourself unstuck is generally what debugging is. So again, shouldn't be news to anyone, a bug being an error in a computer system. But I wanted to highlight some specific types of bugs that we're going to run into and sort of categorize them in a broad sense. The first type that we're going to run into are the things I think, Monica, you might have been asking about, and this is what I was mentioning. There's things called syntax errors or type errors, sometimes name errors you might see. These are the sorts of things that are a misspelling, or you put too many spaces somewhere, or you didn't use the right punctuation mark or something like that. And Python, when it boils down, if you imagine that chart that we looked at with Python at the top and machine learning or machine language at the bottom, when it boils down to machine language, the program that does that is called an interpreter, the Python interpreter. So we refer to that a lot. And when the interpreter looks at things, it'll catch these types of errors. It'll catch syntax type errors, and it'll break, and it'll throw an error at you and say, hey, there was an error. It'll give you some information about where that error was. Again, we'll do lots of this, so we don't have to dig into it too much. Just the type of errors that could be caught by your interpreter are a certain set of errors. Another broad category are logical errors. As your algorithm, and as we're trying to solve problems with algorithms, you're going to build logic into it. You're going to have logical phrases and terms that you're checking for true and false statuses of things. If you make a mistake in there, your interpreter is not going to tell you about that. You have to approach finding those in some other way. So testing is one of the things that we use for that. We'll talk about that here in a second. But this is a totally different set of errors. Your program won't break on you, but you'll get a bad result. And they're just as damaging, so you have to approach fixing them in different ways. Another error that I want to call out kind of on its own, especially for beginners, is what's called an off by one error. And we're going to do this today, where we talk about different data types, like I mentioned, and some of those have orders that the information is in. A list, which we'll talk about a lot, is one of those things. And the order of those objects in that list starts with 0, typically. So it's easy to be off by one if you start counting at one, count up to five when there's only four things because it starts at zero. So just be aware of this as a thing that can happen. Make sure that you're paying attention to the number of items in lists and their index, or else you get an off by one error. And the idea here is that the process of debugging is systematic, trying to find and fix these. We'll call out some quick ways of doing it. There's a ton of different approaches. And again, we're just going to kind of allow it to naturally happen as we go through the course. We'll do some together. If you guys run into problems, please raise your hand and tell me where you get stuck, because it's a great opportunity for us all to debug each other's programs. There will be issues you run into that I couldn't have possibly thought of. I'll make mistakes as I'm typing things, even though I've done this a bunch of times. So let's do that as a kind of collective learning experience. But any questions about this as a general idea before we move on? Cool. All right, so testing as an idea, it makes bugs a lot easier to find. It's something that should be done continuously all the way through. We're not going to spend a lot of time doing it. It's a bad habit to not do it, and shame on us for not. The issue with not doing is you'll create what's called tech debt. And are you familiar with that term? Anyone that's been around can define tech debt? No.
I have never even heard of that.
It's like financial debt. When tech debt is when you're working on a project and you make decisions, and you have to make decisions. So you make many of them. Every decision you make sometimes comes with a cost later, right? So sometimes you're fixing one bug that's mission critical and it stopped your site from working and you had to fix it, but it uncovered a secondary bug. And you're like, I don't have time to fix that. I have to get the site back up. I'm going to push it with this other bug still there and not solve it yet. That unsolved bug that you put off to later is called tech debt, because it's still a problem. And the more you do that, the more those problems rack up, and you have this really long to-do list of things to fix. And the longer a project goes, the more tech debt you're likely to have. Tech is a way to prevent that from happening. Continuously testing as you go is a way to stop that from happening. A really wonderful way to do it is doing what's called test-driven development or test-driven design as well, where you start by writing your tests and then you write your program. It's a little mind-bending at first. It's something I definitely encourage you to stretch yourself into if you have, as we do this course, the way we're going to do it, we're not going to do a lot of testing. Next week, when we talk about algorithms in practical application and we start using them to solve problems, the things that we use will have tests built into them. We'll talk a little bit more about them then on the framework of tests, how to use them, how you might use them. Yeah, Tom, you got a question?
I'm going to ask you if the opportunity comes along at any point to mention security up front, since we're doing development here.
Mhm.
Security ideally is going to start way up front. If I know it's day 1 or 2, it's not going to be hitting us hard, but
Yeah.
if you can bring that up, that'd be handy.
Yeah, absolutely. And that's the thing, is just like testing, Tom, that's a great point, is, and it's not layered into this course directly, but security should be considered all the way through. At what points people are going to be able to access systems, be able to access parts of your development process, who has access to what it should be designed into the process before we really get going. So that's absolutely true. And yeah, it is a little out of scope of getting people familiar with the basics of it, but it is just as fundamental to a real project as testing should be. It should be done in conjunction with all steps of it. Yeah, it's absolutely a fair point. Anything else? Any other questions? Comments?
What program do they use to test? I know I've used Jest before with JavaScript, but
Mhm.
I'm not completely familiar with Python. I've done a little bit.
Yeah.
What
Yeah.
would
So
they use for that?
one real common one is just called PyTest, PY test.
Okay.
And that's pretty easy to use. But again, that's not something we're going to dive real deep into. We're not going to do any direct testing, but it's a real simple, common way to write manual tests and have them included.
I gotcha.
Yeah.
All right.
Yeah. And for anybody that's kind of thinking about exploring this world and figuring out where to go, this whole thing about debugging and testing, just like being a Linux administrator, we touched on Linux and doing Bash a little bit. That's a whole job and world you can do and a career you can have. Testing and debugging and doing QA is an entire thing. It's a whole profession. And it's it's a very thorough plan you have to make from the beginning. Something has to be done the entire time. And if you think about projects the size of some of these places like Google, can you imagine finding bugs in something that size? That's ridiculous. There's a ton of people that got to be involved in that. So testing, debugging, not this course. We'll mention a little bit. We'll do debugging hands-on, but not in a formalized, structured way. Be aware that it's something you definitely take and run with as a further piece of study, though.
So Jeff, just not just to stay on this topic just for 30 seconds.
Sure.
We're using GitHub, correct?
We will, yeah.
So will you be able to at least point us to information on how to set up either PyTest or some other mechanism to run automated tests while you're in GitHub and your code is being combined or uploaded or whatnot? I'm used to using Jenkins where developers would upload their programs, and then this automated test would run to make sure that what you added didn't break what's already there.
Yeah, we're definitely not going to get to the level of doing Jenkins or anything like so. Like, we're going to talk about that towards the end on what those things are, like a continuous development and continuous integration cycle would be. But we're not going to go through the steps of actually doing it. So when we do GitHub and when we talk about GitHub, it's going to be more just how to basically interact with code, pull it down, contribute back to it, do a pull request kind of thing. That level of integrated testing is going to be a little bit outside of what we do in this class. But I can point you towards, if it's not in the free resources, I'll double check, but I could definitely list PyTest and like how to put it in, and you can run it. I'm pretty sure it's built in to Python Anywhere. We can actually check today because I would assume it would be. I think it comes standard with Python. So if it's not something you already have, again, we can make sure that we have documentation listed in the free resources, and we can spend some time going over it, maybe before class, after class, something like that. Does that work?
I appreciate it. Thank you.
Sure. Cool. Anything else before we move on?
Are we going to touch on documentation and kind of best practices there?
Not really. No. It's similarly to testing, debugging, something that should be going on the entire time. And there are some pretty cool like frameworks that'll do it, like Sphinx and stuff like that can do it in an automated way. But no, we're not gonna touch on actually writing the full-on documentation for a project or anything. But that is something that should be done in tandem with any development effort as well.
Okay, thanks.
Yep. Great questions. Anything else? All right, cool. So keep them coming. So what we're going to do is we're going to go into programming basics using Python, right? So we're going to talk about stuff that most of what we talk about today is going to be broadly applicable. We're not going to get into the deep inner workings of what's going on totally under the hood. We'll mention it where it's relevant, but I want to keep focused that this is not a Python course. So we're not going to go into the depths of the language itself. We're going to go over the pieces that we need to use it, right? And we're going to get the basics today. We'll do a little bit next time. But for that, we're done with slides. So let's go into Python Anywhere. So I think I got something. Here we go. All right, I'm gonna start off my dashboard. Just kind of get everybody going. Let me move some of the Zoom stuff out of my way. Sorry, I got too many things popped up on my own screen. And we're going to slide over on this top into consoles and make sure we get the same starting points, because what we're going to do today is going to require 2 consoles for us, and 2 is the maximum number we have on the free version of Python Anywhere. So if you've got one already open, we're gonna have to close it. If you got more than 2, I mean more than 1 open, we can have 1 open, that's fine. So when down here where it says your consoles, if you have more than 1 listed here, you got 2 listed, hit the little blue X on 1, close it out, because we're gonna need 2. If you don't have a bash console open, which I think pretty much everybody had one when I checked in, and I did check up on y'all, so if you weren't working, I know. No, I'm joking. If you don't have bash console open, just over here under other, where it says start new consoles up here at the top, we're gonna do this one that says bash. Again, that's short for born again shell. These consoles are also called shells, so we'll use that term a couple of times. But so whatever case may be, 1 console open now. We're gonna need 2 eventually. Let's go into that bash console and get started with what we're gonna do today. All right, so I'm gonna zoom in a little bit so it's easier, hopefully easier to see. And we're going to dive straight in with how we get to Python from here. Now, again, back on the last screen we were at, we could have just opened a Python console directly. But what I want to show you is, again, a more common way of doing this that is broadly applicable to other programming languages, right? So there's a way to access an interactive shell through the bash shell, the born again shell, right? So we're in bash now. We know that because we have our tilde and our $sign. This is, real quick, who remembers what the tilde means? What it stands for?
Our home directory.
Yep. And then this thing means we got control. in our bash console. So what we're going to do from here is we're first going to check to see that we have Python. We should in something called Python Anywhere. But again, for demonstrative purposes, we're going to put this command in Python 3. So the name of the thing that we want to check to see that we have, space dash dash version. Everything here is lowercase. Python 3 is all one word. When I hit enter on this, it should list out the version of Python that I have, right? We're going to talk about versioning again when we go into version control systems. When we talk about Git and the things that we were talking about a little bit before. But this, again, shouldn't be super unfamiliar to people. We talk about things in terms of versions. This is the one that is available to us at Python Anywhere. It is not the latest version of Python, but it's good enough for what we're doing. So we don't need the most cutting edge thing. 3.10.5 is fine. Quick note about that's really important. Python versions are really super important. 3 is the major version that's been out for a few years. You're probably not going to run into 2 much, but you may do documentation about it and things like that. They're substantively different. If we'll talk about this versioning system more, but this first number, generally not backwards compatible with older versions, whereas this number should be. So like 12 should work with 10 still, like 3.12, I think is the newest. That should work just fine with 3.10. And then 5 is just patch fixes. So any little bug fixes that they do along the way, which again should be backwards compatible. So this is how you check you have Python on your system and what version you're using. Because if you start doing different Python projects, each might have different versions. You may end up running into a situation where you want to use different, right? So Python and versioning, kind of lock that in your head as a important pair of things to keep track of. So what we're going to do now, we know we got Python in our system, is we're going to go into the Python interactive shell from here. So we're going to go into it and we're going to come right back out of it. So I want to make sure everybody can get in and out. So if somebody gets stuck, raise your hand and tell me. So I want to make sure that you can get in and out before we move on. Because I've had people silently sit stuck and not say anything and be lost. Don't be that person, right? So what we're going to do is just type in Python 3 by itself. No further commands. When I hit enter, it will take me into the interactive shell. And I know that because it tells me the version information again, gives me some other things, date, time, some other commands I might want to know, like type help, credits. This 3 little arrow thing here showing differently than this bash command shows that I'm in Python shell and I can give Python commands. So all those bash we did before are no longer going to work. If I type in like ls here, it's going to give me this error. Name error. It says, I don't know what ls means. That's not a thing. We're not in bash. So to get back to bash, before we do anything else in Python, before we talk about get back to bash, again, this is the part. If you get stuck, raise your hand, let me know. We're going to type the word quit, open parentheses, close parentheses. We're going to wrap up with what this is. This is actually a Python function. This is how you get back to your bash console. So I'm going to hit this, back to the tilde, back to the $. And I can do clear, I can do less, commands like always. Questions? Can everyone do that? Everyone able to get into and out of the Python shell? Anyone stuck? All right. Too late now. I'm never coming back. No, if you're stuck down the way, raise your hand. I can remind you how to do this. But for this, we are going to be in our Python shell. So from here, let's talk about the data types that we're going to be using. And this is, again, a progression of all these things at some point are boiling down to ones and zeros. That becomes relevant at some point. But these are going to be the building block pieces of our code. Yes.
I have a problem. It's telling me that when I type in Python 3, it says name error, Python 3 is not defined. When I have the right things.
Okay. Are you typing it in when you have a $sign next to it, or do you already have these?
No, there's no $sign.
Yeah, you're probably already in the shell. And so that sounds like it's saying that it doesn't know what that is because we haven't defined a variable with that name. So if you have these 3 greater than symbols, then you're in your Python shell. That's where you need to be.
Yeah, so you have 3 of those.
Perfect. Cool. All right. So then, yeah, the bash commands aren't going to work. We're going to type Python things. So you're right where you need to be. All right. So data types. The first data type we're going to talk about very simply are integers. So all the numbers 0 to 9, they're no decimal point or anything like that. And they're quite literally, you just type these numbers in. There it is. So like 1, 9. Python knows what those are. It recognizes those. Similarly, you could put in floating point numbers. So you could do 10.5 and it knows what that is. And it's like, great, 10.5. You could do arithmetic with these things. So You can add them together. It understands the data. You can do subtraction. Just directly writing it in. It doesn't matter if you put spaces between these numbers. Doesn't matter if you don't. It's best practice. There are styles to these things, which I'll reference as I can. Best practice. There is a style guide for Python that I'll reference again as well. It's linked in the free resources called PEP, Python Enhancement Proposal. The current version is PEP 8. And it talks about those sorts of things like how to space.
So
these
question,
numbers and all that kind of stuff. Yes.
if you go to your example of 2 and -1,
Mhm.
how does Python know it's not 2 and -1?
Because it doesn't treat this as a unit. These are two different things for Python. The space in between is irrelevant.
They would have to be defined as separate integers for Python to know that it's a -1 and a 2.
Yep.
Okay. Thanks.
Sure. And that's what I mean. It's like sometimes those things, again, it'll catch you as being relevant. Sometimes it won't, right? So this right here, it doesn't recognize this as being -1, and it treats that as. So simply multiplication, very simple. You just do the asterisk symbol. Use. Oh, there we go. Got held up for a second. Have some internet aid. And then when we get to division, it gets a little bit interesting because if you divide. Turn a floating point number. So it is relevant to you. If you don't want that to happen, if you want to make sure that you maintain integers, you can do float to whole number and return that, right? So if you want to make sure that you just have an integer, you do floor division, which is 2 division signs together. And I'll give you 3. Another handy trick for things is the modulo operator, which is a percentage. And this will give you the remainder. If we do 8, the remainder, right? So 50, 5 can go into 8, 15. Arithmetic, handy stuff, might be needed for solving problems. Again, not a math class, but I'm showing you that it can be done. This is how we do it. The last thing that might be relevant in writing simple programs or even complex ones is exponents, and how that's done is just doing the base and then 2 asterisks and then whatever power you want to do it to. And it can do all those things directly. So that's the first 2 types of data, integers and floating point numbers. So integers and floats. And they are different. They're treated differently under the hood. But again, it's boiled down to bits and bytes at some point. And the way Python treats numbers, that's a whole world of interesting things that I encourage you to read up on. For now, just understand we can write those in directly in that way. The next type of data that we're going to talk about is called strings. Now, strings are any set of characters that we would consider like text is probably the fastest way to call it. And in Python, we represent a string in quotation marks. We can use double quotation marks. Have to be open and closed, so that's contained fully with double quotations. And you see when it returns it back to me, it can be these single quotations. You can also use single quotation marks. That's okay. That will be accepted. What we can't is we can't mix and match. So if we try to do double on one side and single on the other, it's going to say, no, don't do that. Syntax error, don't do that. Now, there's a whole bunch of stuff to be done with strings. A lot of what we're going to be doing in the next week when we do our algorithmic problem solving, and I give out some problem sets to work with, we'll be manipulating strings and doing some work with it. So we'll talk a lot more about what we can do with it. I just want to get you to understand that it is representative of what you would write down, what we would consider text. So it can contain special symbols and characters and all that sort of stuff, and won't break it. Put $ signs wherever in there, and that's totally fine. So it's basically the ASCII and UTF-8 encoding that we talked about. This is where those things would be. Any questions about those? It's pretty straightforward so far. So all the things I've written so far, where I just wrote directly a number in here, say that's like 10.5, or this string in here where I put in quotation marks, these are all what's called literals. You may see people call those along the way. That's when you just directly write in the data type itself. There are built-in functions in Python for all of these things where you can define a thing without giving it the actual substance of it. For example, you can just do int, open parentheses, close parentheses. That is an integer. And what we can do with this is we can set the type of information, right? So let's say you have a form where people put their phone number or something like that, and you want to, dollar amounts, who knows? And you know that they're going to write that in as text. It's going to come to you as a string. You want to convert that string into an integer and do some math on it, right? So this is how you would do that. You use the built-in function. You say int, and then you pass it a string, and it'll return the integer version of that string if it can be pushed into that. If you have something that can't be made into an integer, it'll give you an error that says I can't do that. So that's one handy in on that works. There's strings that are built in as well. Those are called built-in functions. So another way that you might see them referenced in documentation and in examples. Sometimes they won't write what's called, again, literal, like this, where it's an actual string. Sometimes they will use a built-in function like int or str, the built-in function for string. Just know that all these data types have those. So sometimes they're handy, sometimes they're useful. Also, a quick note, this is kind of fun, about the different data types thing. So integers, like we said, can do arithmetic, say like 9 times 9, right? We get 81. If we do a string 9, we can do this. This won't give us an error. What it's going to do is it's going to repeat the string times. It doesn't understand that string is the same as 9. It's not the same for it. It's two types. So you can use that to your advantage again if you're trying to repeat strings or something like that. You could just do straight multiplication. You can do, concatenation with them using the addition sign and stick them together, stick two together. So there are some circles of crossover in the functionality between the arithmetic do with integers and floats and what you can do with strings as well. Cool. Any questions on any of that? Nice. So the last sort of simple data I want to talk about is called the Boolean values. And if you don't know what Boolean means, it's really just a term that is true or false. So it's covering both true and false as terms. And in Python, those words true and false as capitalized words, so true and false, are what are called reserved words. These words exist in Python already. You can't use them for other purposes. You can't like make a thing called false with a capital F. It'll say that it'll interpret that as not being true, basically, right? Whereas lowercase false gives you a name error, right? So case is important to write in Python. True and false are reserved words. You can't use them for other purposes. It's not often that you're going to set things or use these directly, but you're going to use it in logic when we start building logic and our algorithms. The things that we're doing moving forward. You're going to use this a lot for logical checks. All right, so those are the basic, again, pieces of data, the data types that we're going to use to build more complex things, and then sort of groupings of these in some fashion. We'll talk about why we would choose these, one versus another a little bit more next week. So right now, let's just introduce you to some of the basic types that you're going to be using a lot. The first one, most definitely, is the variable. So a variable, just like, algebra class, is something that is representative of a value that might change throughout the course of your program. So a variable in Python can be any name that you want, really, except for a reserved word. Like I said, true and false, things like that. There's a handful of other reserved words we're going to run into, like in and if and things like that you cannot use as a variable name. But pretty much everything else is good. It can't start with a number, so you can't put a 1 in the beginning of it, but you can put a 1 at the end if you needed to. And then there's some best practices. Again, going back to the PEP 8 on how these things should be done. The preference, the standard, what they call Pythonic, which I think is a funny word, way of doing is lowercase variable name. And if you have two words, like say my variable, you do what's called snake case, where you do underscore in between the first and the second. You can do camel case, where you capitalize the second word. It's possible, but you don't typically do that. What you're going to see most often and what you usually do is what's called snake case, my variable. And then what you're going to do is you're going to set it. And this you may be tempted to call equals. It is not. Don't read this as equals. Read this as is. This is the verb is in Python. So when you write this symbol, you'll be tempted to say equals, but it is. So we're going to read this, say my variable is, and then we give it some kind of value. So any of the data types that we talked about so far can be the variable for this. So like we say it's 7. Tab complete, the bash shell works here in Python. If you set a variable like I did with my variable and then I hit tab after typing the letter M, it just fills in the rest for me. So use that, it's handy. And now that I've saved that variable, I can recall it, I could do things with it. So I can do my variable, I could do math with it, right? I can make other variables storing the results of that math. I could do more complex things with it. What we need to keep in mind with this will be relevant later, and tying it back to the binary that this is boiling down to, a variable is a named space in memory. Who remember from day one, way back when, between memory and storage? So when I say it's in memory, what does that mean?
Random access memory.
RAM?
Sure. Okay. That's both true and the same answer. But what does that mean? Like, what is random access memory versus storage? Like, what's the difference between storage and memory generally?
Storage is where we keep stuff that we may use in the future. RAM is something we use as the CPU is processing information.
Absolutely right. So memory, or RAM, is temporary. It's something that's not going to last from session to session. Storage is something that you want to keep long term. That's where your database and things like that are going to be, right? So in web application terms, that may be things like a session. Information that lasts for an entire session might be thought of as memory, things that are stored in memory. Google is a notorious memory hog on your machine. If you use Chrome as your browser, the way that it's so fast is that it just sticks a whole bunch of stuff in memory to index quickly, look it up faster instead of grabbing it from their servers. You know, handy trick, it works well. But the idea here is that these variable names that you make are also just a named space in memory. So you can change them, you can put different things in them, but what you're doing is setting aside a chunk of your memory for that thing. It becomes relevant when we talk about different changing sizes of some of these collections that we're going to get into. This variables are one of the first simple collections where we can just kind of hold these things and do stuff with them. But we're going to get into more complex lists and like that take up more space and are more relevant when we try to change them. All right, so variables. Any questions about variables up to here? Cool. So one example of like how we might see those int and things like that is you might see them as variable values instead of doing, you know, a placeholder like a 0 or something, the function, and then it'll set it as 0 automatically, right? So also little useful tricks. So let's talk about lists as our first collection. This is the next 4 data types we'll talk about are exceptionally useful. First 2 are going to be ones that you're definitely going to need when you just, it'll get you done for just about 90% of what you're going to probably be doing in the beginning. The last 2 I'm going to talk about because you'll see them and run into them, but you're probably not going to use them as much unless you're a little bit more advanced, right? They're very handy for certain things, but lists and dictionaries are the first 2 we're going to talk about, and they're exceptionally useful and all over the place. So lists in Python, a list is something that is contained in square brackets, so open and closing square brackets, and is any number of data points, data types. Could be list itself, it could be integers, whatever you like, separated by commas. So we'd have like the first item in the list, comma, you know, another thing here. We can have another list inside of it. We're not going to do that this time, but we can have any data type in there, and we can save it in this square bracketed. This is a list. I'm going to save it in a variable so we can do some things with it here in a second about it. So I'm going to say my list is opening square bracket, whatever values I want separated by commas, square, closing bracket. List, and the thing to keep in mind about them is they are ordered. So this list, every single time I call it, is going to be exactly in this order. 9 is going to be first, another thing is going to be second, 10.5 is going to be third, every single time. These are 0 indexed. So the first thing in this list is at index 0. This is where that off by 1 counting error can come up. So there's 3 things in this list. If the first one's 0, and I want to grab the last thing, what index is it? Anybody?
2.
2. There we go. So the way we would do that mechanically is we put the name of the list that we're going to do, opening square bracket, and then the index number that we want to grab. So let's say we want to grab that last thing. We do 2, and it'll tell us what that is, 10.5. Another handy thing is if you want to grab the last item of a list, you don't know how long it is, you can use negative numbers for there. You can say -1, and that should be the end of your list, even if you don't know where the end of the list is. So that's useful. There are a lot of cool things we do with lists. We're going to get more into it next time. We start doing a little bit more of changing them. That is one of the aspects about them that you should keep in mind. They're what's called mutable or changeable. So there's something that can be changed without requiring a fresh copy of a thing. Strings that we talk are immutable. So if you do something to a string, you're making another string. This, however, you can change in memory without making a new thing.
Yeah.
So, yeah.
Where did that, when you put the my list -1, where was it subtracting that to get to 10.5?
So that's the, yeah, that's the, so if you think about it kind of like a number line where 0 is this place.
Right.
And then it's like going, when I put -1, it went left around to here instead of going
Okay.
right to get to where it needed to be.
Gotcha.
So if I did, for example, my list -2, that should take me back to this spot here.
Right.
Let's see. Yeah. So it takes me to the middle place, which
I got it.
if I was going from the front, that would be my 1 index. That makes sense?
Yep.
And then either way, if I do 3, it's out of range, so I get an index error. And I think -3 should probably give me the same. Oh, no, it doesn't. It goes all the way back around. So there we go. Oh, wait, no, it'll be -4 on that side, right? Because it would be 1 indexed from the right-hand side. So again, this is how the off by 1 error happened. I just did it myself. I was like, oh, -3 should be out of range, and it wasn't because I was off by 1. So there you go. It's easy to do. Any other questions? Cool. So all these things that we talk about, all these collections in Python are only classes, which was a data type we're going to talk about next time because it needs some time devoted to it on its own. It's one of the coolest things in Python, and it takes a while. So we're going to put that off till next time. But all of these things technically are under the hood at some point. That's what they are. And all classes have built-in methods. So you can do things that are built into this. We'll do some more playing around with it next time. But you can add things to the back. You can take things off the back of a list. For example, so we do like my list. And if I wanted to add something, I could do .append, open close parentheses, and then, add something. Put in those parentheses whatever it is I want to add. And now if I look at my list, it should be at the end of that list. So there's that new thing added in there, right? So this dot notation. So there's a dot, the name of some kind of what's called a method, but it's some kind of function. We'll get into those definitions here in a minute. And then something in parentheses. This can be done with just about every one of these collections we're going to talk about. And once we go through the introductory of these and we move on to play with them on your own, I really encourage you to look up in the documentation all the cool things that they can do, like what strings can do built in and what lists can do built in, because that's part of the power of Python is all this stuff has really cool stuff built into it as data types. So that's lists. Let's talk about dictionaries next. Dictionaries are also pretty cool. And they are going to be stored in curly brackets, so open and closing curly brackets. And they're going to consist of a key, colon, and a value. Now, it doesn't have to be the word key and value. I'm demonstrating what these are called. So the first part is called the key. There's a colon, and then there's the value associated with that key. And then you can add a comma and have other things in there, right? So this key value pair construction is very common. It's very useful for like making associations, mappings, that kind of stuff. Solves a lot of problems. Very, very, very handy. And broadly used in computing. In Python, it's called a dictionary. In other places, you may see it called a hash map or hash table. But the main thing to remember is the key value pair. That is the most important part. And we can reference things by the key and get the value. So let's do a quick example of this. And so I'm going to do key value pairs with my kids and their ages. Everybody, maybe take a break. I got a bunch of kids. It's going to take a minute. But I'm going to put in their names as the keys, and then I'm going to put their ages as values. The idea here, if we have like a real world example, because I have so many children, I might forget their ages. So let's go ahead and save this into a variable. So my kids is terrible English grammar, good Python. And now we have this dictionary. And what we can do is we can reference things out of it, not by index. This is not indexed. So this is unordered. That's a difference between this and lists. Oh, and as a quick side note, lists in general terms outside of Python are called arrays. So if you're doing like JavaScript, you know them as arrays. This you would know as objects in JavaScript, but dictionaries in Python, lists in Python. So dictionaries are not referenced by index. So if I try to do, say, my kids square bracket 0, hoping to get the information for this first entry, I'm not going to get that. I'm going to get what's called key error. It's going to say key error 0, which means that there is no key 0 in there. It doesn't mean that it was bad. It doesn't mean it was out of range or anything like that. I could have used 0 as the key. I could have used numbers instead of strings. There just isn't one, right? So the way I do reference things by key is just like that with square bracket, but then I put in a key that exists. So if I know that the keys in my dictionary are the kids' names, if I put in the key, I get back the value associated with it. So I get the age associated with that. Makes sense? Everybody tracking this? Cool.
Can you explain that one more time? Sorry, I'm kind of
Sure.
I'm trying to
No
keep
worries.
track, but I'm kind of
Yeah, absolutely. Absolutely. So when we reference things out of a list, we reference them by the index number because it's an ordered thing. So it's from 0 to whatever number of things you have. The dictionary is not ordered. So whatever order you wrote it in is not the order it's going to be retrieved in. The way we retrieve them is with the key of the information we want. So in the dictionary I have as an example, the My Kids dictionary, all of the keys are my kids' names. So if I want to say, like, how old is my son Max, I pass his name attached to the name of my dictionary, the opening square bracket, and then the key that I want to retrieve, closing square bracket, and it should give me back the value associated with that key from my dictionary. Does that make sense?
Yes, thank you.
Sure, absolutely. And so this is really important to understand. This is the power of dictionaries, is being able to look, or hash maps, hash tables generally, is this ability to quickly retrieve something from the key, to get the value from the key. That's why these things are cool. We'll talk about more of this next week. This is just an introduction to what the thing is. All right. So let's get on to our next set of things. Next set of data types that we're going to talk about real quickly. Again, so those two, lists and dictionaries, the main two that you really, really want to focus on understanding and knowing, getting good with. We'll use them as practice, and they'll get done most of what you need to do. The next two we're going to talk about are good to know. You're probably not going to write them off the bat. You'll run into them. It's good to understand a little bit about them. The first one is called a tuple, which is a funny sounding word, and I'll just go ahead and spell it out. So I'm going to make a my tuple, T-U-P-L-E, and it's going to be stored in parentheses. And this, like lists, they're ordered. They can hold any number of other things separated by commas. So we can do, a mix of things. We can do strings. We can do integers. We can do floats again. That's all cool. Separated by commas. And now we have my tuple. And so this is like a string. It's going to be 0 indexed. And we can reference things out of it just like we did with a list. I'm sorry, string is like a list. But unlike a list, these are unchangeable. These are immutable. So anytime we do any operations that add things to this or take things away from it, it's going to make a copy of this. So if you're going to have operations like that, you may not want one of these. And that's why, again, you're probably going to use, especially when you get going at first, list more. Is there a thing that's going to be able to add and stuff away in your algorithms? You're most likely going to be doing that. There are purposes to use tuples. It's more to be aware of them as a data type. Any questions about tuples? Pretty straightforward. Cool. All right, so the last one, before we move on to even more complex things, is the set. So a set is similar to a dictionary inside curly brackets. Unlike a dictionary, it is not going to have key value pairs. So it's just going to be whatever data you want to put in there. Makes them different. I don't want to keep using the same example data. Maybe I could stop doing that and won't mix those. 1.4, there we go. All right, so now we can put it into a set. And so what this set does, unlike a dictionary, is everything in here is going to be unique. It does not have doubles. A dictionary has to have unique keys, but the values could be repeated. This has no repeated data of any kind. So if you try to add something in here that already exists, it won't let that happen. So that's one reason you may want to use a set, is if you're looking for reasons to remove duplicates. It is optimized for looking for things called membership to see if something is just in this. Think of it like a bag. Think of set like a bag, right? And so it can quickly tell you if something is inside of it. Doesn't matter what position it's in. But you're not going to reference it by a key. So what I'm talking about with in is we can just ask Python. We can just do as a logical statement. I can just say 9 in my set. It'll tell me if it is or not with a true or false, a Boolean value. It's useful for doing exactly this, right? So true, that is in my set. You can also do dictionaries and lists. So you can use to check for membership of those things as well. But sets are optimized for that. That's what they're designed for partially. The other thing that they're designed for is stuff, again, you're probably not going to be doing right away, but it's useful down the line, things that are like set operations mathematically, like union, intersection, for instance, that kind of stuff. Sets are great for that. You start doing matrix operations, you start doing machine learning, sets will be really useful at that point. But when you first get going, you're probably not going to solve a lot of problems using sets. But they are handy if you want to, again, remove duplicates and you know you're doing set operations. Cool. Any questions there on lists, dictionaries, tuples, or sets? All right. Excellent. So now we are going to shift gears a little bit to talk about the last data type for today. And we're going to write it in a file that we're going to save instead of doing it here in our console that appears and doing it. So we're going to start moving into doing things that we save and kind of work and develop further. The last thing before we do that is just by way of description, it's a function. So all these things we talked about up to now, these data types, you can think of them like nouns in a language, right? So they're things, ideas, right? Stuff that exists out there that you're going to kind of do things with. The functions are going to be your verbs. They're going to be things that actually create action and cause things to happen. So let's go start making some things happen. The first function, again, we've already seen it. So quit is a function in Python. We've already seen those built-in functions with int and all those things. This is a function in Python. This is how we are now calling a function to exit our Python shell. So this is a function that's built in. Type in quit so we get back to our bash console. And let's move into writing our own functions and dissect exactly what those functions look like syntactically. So a couple ways we do this. We could go through the built-in code editor and UV, like. I mean, think of this kind of like I don't ever watch one of those old videos where they have kind of the regular workout, and there's like a super hardcore workout with these like jack dudes doing crazy versions of burpees, and then there's like the slower version. You could do V if you want to as like the jack hardcore workout version. I'm going to go through the GUI for everyone else as like the mid-range version, but all we're going to do is we're going to make a file right here. We're going to start building our functions in there and build our first application. I'm going to do that with the GUI. I'm going to keep separate tab. We're going to come back to that console. We're going to need it here. But again, like I said, we're going to need a second console here in a second. So if you do have more than one console right now, go in consoles real quick, get rid of it. Get rid of one of them because we need two. So what I'm going to do is I'm going to slide down here. I'm a little bit, your thing may not look the same proportions, but you're going to have a directory section, and then it'll say enter a new directory name. I'm going to scroll down where it says files. Similarly, enter a new file name. Whoa. I need to be highlighting everything. And I'm going to type in main, main.py. Normally read as py, like in Python. And that's the standard file extension for Python files. Typically largely irrelevant, but when I hit that new file button or enter, it'll take me into the built-in text editor for Python Anywhere, which actually is pretty slick. This thing's pretty nice. I like it. It's not bad at all. You'll see at the top, we have a full directory path that shows us exactly where we are. So we have our tilde broken out as /home/hired_labs, whatever your username is. Hopefully it's not the same as mine. Can't be. And then the file name that you're in, right? So this is really good to know where you're at. It's like print working directory, just put it there at the top. And so just like in V, which is also text editor, we're going to start out on line 1. Each line is going to have a number. That's going to come in handy when we go into bugging or debugging, because when you look in your logs, it'll say which line broke. So it's handy to know which line you're at. We always start up here on line 1. So before we get going on defining this function, is what the first thing I'm going to mention some.
I'm having trouble.
Yep.
I'm having trouble getting there to get another console. I got to go back to the dashboard.
Okay, yeah, sure. So where I am now is in files, right? So if you go to files, yep,
Okay. Yep.
A-
Files.
And then you find under where the heading where it says files, there's a enter new file name input box.
Yes. Yes.
And then type in lowercase, all lowercase, main, MAIN, .py, all one word, all lowercase.
Dot py.
Yeah, Papa Yankee. Yep. And then hit new file, and that should take you straight to where we are here. I say we, assuming everyone else is there, since no one else raised their hands that they're stuck, but it may just
Yep.
be me.
Okay. Gotcha.
Cool. All right, right on. Cool. All right. So here we are. And we're going to start with defining our function. The first thing I want to mention before we do this is we're going to go through a couple other concepts. We'll go deeper into them next time, called control structures. So the basic beginning control structure is called sequential. And every time you run your program, or what we're going to do here shortly, the interpreter, the Python interpreter that I mentioned before, is going to read your file, this file that we're going to save here, top to bottom, left to right, really fast. So that concept, keep it in mind. That's sequential. That's what the standard running of a program is doing. It's reading the file from this top line, left corner, left to right, top to bottom. So let's get started writing some code for it to read. When we define a function, the first thing we're going to do is a reserved word, def, short for define, because we're defining a function. It's going to expect a user-defined function afterwards, and we do one space after def, and then any name we like. Again, there's some parameters that we follow. PEP8 is the thing. It's linked to the free coding resources. I think someone shared in the chat as well. Generally speaking, best practices similar to so lowercase, snake case. You can't do case, but snake case. So this, by convention, is going to be main. Once again, just like the name of the file, has nothing to do with each other. We're going to talk about this. There's some confusion around names of things. We're going to see the word main about 3 times. Please, if you're confused, ask. The whole purpose of spending as much time as we're going to writing these lines of code, we're only going to write about 8 or 9 of them maybe, is to make sure that we understand each piece and why we're doing it, right? The why is really important. So if you're confused, ask. We'll double check and we'll hit on this. It is by convention that I'm writing the word main, though. This could be any function you want. This function name it's arbitrary. And then we have open and close parentheses. This is where our inputs will go. We have 0 inputs in this current function. We'll do some more inputs on stuff later. And then a colon. Now this colon, I can actually zoom in a little bit so it's a little bit bigger. Maybe that'll make it easier for everyone to read. This colon indicates that something should happen next, right? So after def, it expects the name, it expects inputs, and then it's going to expect this that will tell it to expect an indented code block. This is when I hit enter here, you notice that it moves me down a line. It also moved me over 4 spaces, 1 tab, right? So I could hit the tab to get over, or I could hit the space bar 4 times to get over, which you cannot do in Python. This is very important. You cannot mix tabs and spaces. So you cannot use spaces on one line and then tabs on the line. You'll break your program. It's annoying, but it's a fact of life in Python. So be aware that 4 spaces from the end or 1 tab is 1 indentation level. It's a very important Python concept. So when we write our functions, the first thing we do after the colon is go down 1 indentation level and define the actual meat of our function. Everyone tracking on that? Questions? Cool. And if you haven't, anybody as a side note, seen the show Silicon Valley, which is pretty old at this point, but a very good portrayal of Silicon Valley and how it actually is. There's a whole argument about using tabs or spaces, and it seems like it's unreal, but that's actually a discussion people have on which one's superior. It's ridiculously deep. So, if you want to read up on that, it's fun too. Just keep in mind it's important in Python. So the next fundamental piece, we're going to get more complex on our functions later, but the required piece here is to return something back to us, right? So the next reserve word we're going to use is return, and then tell it what we want to come back. So like I mentioned before, we're going to do a hello world. As a standard, we want it to return this string hello world to us. So this right here is a very simple but fully formed Python function. It's got all the pieces you need to count as a function. We have our reserved word def, the name of our function, which by convention we'll talk about soon. I'm using main. Open and close parentheses, whatever inputs we're going to have, 0 in our case, colon, 1 indentation, and then our return statement, as this is called, with some sort of return value. So that is the basic syntax of a function. We have defined our function, right? So I'm going to save this file. So I'm going to control save like you save anywhere else. And then we have built into this run button up here in the upper right. This is the moment we're going to need 2 consoles. So this is going to open up a console at the bottom of my screen and run this code in that console. So we're going to do that for demonstrative purposes to show some of these pieces. We'll go back over the other console and run this directly ourselves once we finish writing it. But for now, I'm going to hit this run button so we can kind of see what happens. It's going to do some stuff. It's going to tell me it's opening up, and this is going to open up a Python console inside of a bash console, basically. So it's a Python 3.10 interpreter loading up. And then it gave me these three things. So I said run, and nothing happened. That's because I didn't what's called call this function. Remember when we wrote quit and we exited the Python shell? We didn't write def. We just wrote quit with the parentheses. That's what's called calling the function, right? So what we have to do in our code is we have to evoke or call our function that we have defined. So going back to the sequential control structure, what happens when I hit run after saving, it'll run the most recent version saved. When I hit run, the computer, the interpreter is starting here, first line, first space, reading right to left, top to bottom as fast as it can. And when it gets to here, all it's done is defined this function. And now on line 4, I'm telling it to actually call the function, do the thing. So now when I run it, still nothing happens. Why would that be? We didn't tell it to give us any input, right? So this screen down here, the shell, is called the standard out. And to get things to come out onto it, we have to be explicit. So this did run. You kind of have to take my word for it because there's no way to really prove it. But a way that we can look at it, and this is also a very simple rudimentary debugging technique that you can use all the time, is a built-in function print. So what I'm going to do is I'm going to wrap my main function call in this print function. So you print, open parentheses, close parentheses, around the main function call. I'll save that. When I run this, now we got it coming out on our screen. It says hello world. Everyone able to get to this point? Anyone stuck? Have a question? No?
I'm having problems seeing all of my space, I guess.
One handy thing, if you're looking at this, and the beauty of doing this in this text editor that's built in Python anywhere, is if you have syntax errors, it'll catch those, and you may have a little warning error or a little red X over here by the line number. So look for those, a little triangle, a yellow triangle with an exclamation point or a red X thing. It'll show you that there's an error on that line. So that's helpful with these. If you're really jammed up, we could stay after, and we're going to keep pressing on. We got one more kind of tricky concept that I want to get through today. I want to leave plenty of time for it, right? So I want to make sure we're not in a hurry. Everybody gets their questions answered. But I'm gonna crack on, Chris. If you're still stuck, man, we can get you unstuck afterwards. But we're gonna do what's called refactoring this code. This is the first time we're gonna do this process. We're gonna go through it a lot. Refactoring, as a definition, is just changing the code and rewriting it so that it doesn't really change the deep functionality, but it improves it in some way or does something better about it, right? So we're gonna rewrite the way it's written now. So if you're kind of stuck, it's okay. Anybody else though? Anybody else got quick questions or stuck somewhere that we might be able to get you unstuck fast before we move on? Okay, cool. All right, so now that we have this file written, what we can start doing is we can start calling from other places. We can start referencing it now that it's saved in a location, right? We have a place for it. It lives somewhere. The information is saved. So if I go back to my bash console and I'm in this, our base directory, our home directory, as we kind of call it, somewhat inaccurately, if I list the contents, now I have my main.py file right here, right? So what I can do is I can, from here, call it directly. Just do Python 3 main.py. And it'll likewise print out here. And I can do this from anywhere on my computer. If I go down to the root and I do Python 3, I just need to get back to that place from where I am and call it, and it'll still work. So now we have an application, a very, 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 very basic application written into a file. And this is how we're going to call that application moving forward. There's one other thing that we got to do that's a common best practice construction you're going to see absolutely everywhere to make this a better functioning application, to make this use what Python calls modularity. And we're going to use this all the time. It's a concept that's fundamental in Python. very deep. We don't need to go into huge definitions of it, but the idea here is that we're going to have several files, right? So right now we have this file in our directory, right? We got it in, I'm gonna go back to where we are in our working directory. So we have it in, hold on, this directory, right? So we have our min.py in our home directory. We can add other files in other directories, and we can tie them all together and make a very complicated application. Again, something as complicated as, get YouTube, Airbnb, doesn't matter. We can put those things together and reference them the same way by doing Python 3 and main.py using this import modularity thing that Python does. And we're going to set this up and use it here as a show of best practice. But I want to preface that with what the concept is before we get there, right? So, Ace, you got a question?
Yes. I'm not sure where I got lost at, but I don't have, you know how you have the readme text in main.py? I don't have that as when I just put out the list command.
Okay. Are you in this tilde directory? Do you see a little tilde here? If you're in some other place, you won't see those things.
I'm not in the tilde directory.
So if you type just CD by itself with nothing else, hit enter, it'll take you back there.
Ah, that's real. Thank you.
Yep. No worries. Cool. Anything else? Right. So let's go in and let's refactor our main.py file and add what is called an application entry point. This is a standard construction, a standard phrase in Python. You're going to see it everywhere when we use our web framework called Django week 3, start building a web application. It's going to use the same process. You're going to see it everywhere, all over the place, right? So it is going to employ another control structure called a logical control structure using the reserved word if. So we start off with if, and then we're going to give it a logical statement of some sort to say, check to see if this thing is true. If it is, do a thing. That's basically what we're going to do. The construction that we're going to check, though, this is the standard part. So we're going to do 2 underscores. So if double underscore, then the word name and double underscore. This double underscore thing in Python, if it's leading with double underscores, it does what sounds really cool. Sounds like a metal band name. It does name mangling, which sounds kind of, more impressive than it is. Really, it's just a way to not have conflicts with this word. It's kind of like a reserved variable name. So that's what the double underscores means, right? So we do double underscore name, double underscore. And then we're going to do 2 equal signs. So this is how you check for equality. So we say, if we want to read this out loud, we would say like if this variable, double underscore name, double underscore, is equal to, and then we're going to give it something else. I'm going to give it a string. Double underscore main, double underscore, colon. This sentence, this phrase, not sentence, this is called an application entry point in Python. And this construction is something you're going to see literally everywhere. So I want to introduce it now, even though, again, it's a little bit slippery concept. We look at this thing and like, okay, where's this name coming from? What is this referring to? These are not explicitly called things. We're going to play around with how this works and why we do this. For now, you may just have to trust me that it's the best practice. When we come into class on Tuesday, we're going to show how this works in a little bit more explicit detail. But the idea here is that when it reads in the sequential control structure, it's going to go top to bottom, left to right, and it's going to say, all right, cool, we have this definition of a main function, and now we have this condition. So it's going to check this condition and see if it's true. Without getting into the depth of this, something I encourage you to look at between now and next time, the condition that will make this true is if this file, this main.py file, is called directly. So when we're in our console and we did the Python, here, I'll just put up and get back to my last commands. I do Python 3 main.py. This is calling the file directly. So that will make this condition true. That means it'll execute this code in here. Now, something that's not called directly is what's called imported. So if we got another file somewhere else, which again, we're going to do this next time, we're going to set up another file and import and show how this works mechanically. It behaves differently. So what this is going to give us the ability to do is have several functions in here, write a whole bunch of more code, and it won't just execute it all right away. It'll only execute the pieces we put in. Back in that. Again, this is a tricky concept. This is the I want to make sure we cover in class. This is the endpoint I want to get to. I want to show you how cool this is, but I want to make sure we understand it, at least at minimum level. So if you got questions, ask these questions.
I got a question again.
Let's go. What's up?
Can you break that down one more time about that?
Sure. Sure. So this, again, this whole section here is just a conditional statement, right? So we're going to check to see if it's true. The way that this becomes true is if this file, this main.py file, is called directly by something else. In our case, directly from the command line using this Python 3 main.py. That's calling our file directly. So say, for example, we had another file next to this, which we will next time, and we have some other files. We'll have tons of other files. We can still just call this directly and pull that information from those files in with this little piece of code. This thing is going to be it's called an application. Hold on, let me write it down. This hashtag thing here is called a comment. So the interpreter will skip this. This is for humans to read. So this is called an application entry point. So when we make an application, we include this piece. What it basically says is when our application runs, when our main app do these pieces of code that are inside this block. So we can have other functions up here. So we could say, another function, return 9, right? And it's in there, but if we don't call it in our main block, it doesn't come out. So then we could do all kinds of other things. We can use all kinds of other stuff around. And then this is the control point for what our application actually does for the behavior. Does that help? Does that help?
No, not.
No,
I
not at all.
I was down. I got even more confused.
Okay. So what we're going to do is we're going to add functionality to this application. And the only parts of those functionality that are going to run are going to be down in here. And it's going to make us able to call this in other places. Again, I don't want to dive into adding other files just yet because it's going to take some time. It'll run us over time this time. But what I want to show you is that once you have this, even if you don't fully understand this, again, I know this is really slippery and you may be feeling like, man, I don't get it. Don't beat yourself up. It's more important that you write this down and you have this construction, this framework saved in your file and you have it written down. Again, I'll send this out. Well, I don't think I mentioned this. I'll send this out in documentation afterwards with the recording so that you definitely have this written down, because this framework can be used to make any number of complex applications, right? In the same way that I was just mentioning. Even if you don't understand exactly how this is working, it's okay. What we can do is you can go to something like, let's go to ChatGPT. And let's do like, I don't know. Let's log out of this. I want you counting against me. Get away from me. Okay, well, I guess it won't let me do it without logging in. All right, so what we could do is we could just do any of these AI text things. If we use text generation, we know how to read. And what I would hammer here is if you know how to read the text, the code that you have, fully understanding absolutely every piece of it, a little less crucial. So if we go to text generation, we say like, write a Python script that, and then fill it in with what you need it to do. Say like, converts a CSV file to a JSON file. We'll talk about what JSON is at some point. And it should be simple, doing some things. But as you'll see, we're not going to talk about each piece of this code, but as you can see, it's already following some of the things that we know, right? So here's a function defined, but here's our application entry point. So right here in this piece, and this is what I want to show you, is that it has this standard if, it's like we wrote it, underscore name is equal to the string underscore main. This is a standard in Python, right? So I understand it's maybe a little slippery, but I want you to just get in the habit of using this because you could do what I just did, stuff, and drop it into your main.py file, right? You could just put it over this definition. You could put it next to it as another thing. These import statements, we'll go over what these are and how this works. But this is, again, the CSV. This is a module. This is something that somebody wrote in Python code someplace. We don't need to know exactly what it says, but it interacts with CSVs. Same thing with JSON, which is a data format, very common. We'll talk about it next week. And this is to interact with your system. So these are all things that Python has built into it somewhere. And modularity is what allows us to import those things and then just use them. So this right here, we do the dot notation. This is just using that CSV module. And again, this little piece right here is the thing in Python that makes modularity even possible. So I want you all to get in the habit of using this, because you can now go to, again, something that can generate text for you. If you're not, we don't know all the syntaxes yet, but you have enough pieces to take this, copy and paste it in the framework that we have. We have definition, we have our app entry point, and you can update the you can update loads of files into Python Anywhere and actually test out this converting. If you like, come up with a script of your own, make something that, I don't know, transcribes videos or something like that. And you can run it through here in the same way that we just did. So now I can go back here. If I do this, it still functions the same way. I still get hello world out of my main function like I did before. So that's the idea that I wanted to get to today, is show that this is application written the way it is, and that you can now just fill in more complex things if you want to and run it this way. And we're going to build on this and run more complex things from here. This is how our web application is going to be built. This is like the bare bones part of it. Is that making sense? Or is this everybody getting lost on that?
I hope it gets easier, because I'm still confused, but I hope it gets easier.
Oh, well, okay, so I'll tell you this, man. It's not really going to get easier in the sense of like, it's going to all of a sudden not feel like you're confused, is what I was trying to tell you before. I still feel confused after like a decade of this. It's going to just be, you look back at some point and be like, no, I know how to use that now. And then at some point later, you really do understand it better. This is something, seriously, this little construction, it's tricky. There are lots of articles on explaining how it works, and I definitely encourage you all to do further explanation. Take this piece and have ChatGPT explain it to you. Say, explain this to me, and see if it does a better job. Say, explain this to me like I'm in 5th grade. That's helpful. That helps me sometimes. But again, we're going to see it a lot. We're going to use a lot. This is how Django, I've mentioned before, is the framework we're going to use to build our web application. It uses the same construction, and we're going to access it through the same file. It's not called main in that case. They call it manage.py, but it's going to be the same mechanics. We're going to do Python 3 and then do something through it. So this is how Python really works. This is how Python coding is done. So again, it's not a pure Python class, but this is a piece of Python that we do have to understand at least how to use. So not to scare you, but don't freak out if you don't totally get it. Seriously, it's not something that you have to understand the first time, or you're going to be lost. We're going to go back over and over and over again. The key thing is to have it down, physically written down somewhere that you can use it, run it, and play with it between now and next time, and run your own, try writing. Again, use text generative AI to create something for a purpose. Try making a basic application or algorithm or something like that. When we come in next week, we're going to do more of these things and write more complex functions, using more control structures, and have some practice sets that I'm going to send out on how to write these sorts of things and do, solving challenges, puzzles, and things like that with it. But this is a really good place to end up today. So we have about 4 days till the next class. And I encourage you all seriously to go and try to think up some sort of simple application, like converting files from one thing to another, or some simple purpose of a thing you may actually do, and run it through your own Python Anywhere instance, because you have the framework to run an application. Any other
I
questions?
got something different when I hit run.
Uh-oh, what do you get?
I got it's just like it's _PA run parenthesis u dash home or slash home slash frosted python slash main dot py.
Nice. All right. So what we can do, if there are no questions, what we can do is I can dive into your instance and we can try debugging together and see what you got. Use that as demonstrative purpose if you're cool with that. Anybody got any questions before we do that? Conceptual questions? No? All right. Then let's do that.
How do I give you the permission to do that, to look at this?
Have you done it already?
No.
Okay, so if you go up to if you go to your dashboard.
Okay, let me get to the dashboard here. All right, I'm back in dashboard.
Cool. Up at the very, very top, there's the send feedback forums, help blog account.
Yes.
Click on account.
See that? An account. Okay. Well.
And then you see this upgrade, security, email, education.
Yep.
You click on that.
Education.
Yep. when you click on that, there should be a red thing that says enter your teacher's username, and I'll drop that in the chat so you can copy and paste it.
Okay. So let's see here.
And then once you do, you should pop
Gotta
up
find
here.
where that. Let's see.
Anyone else stuck? Got a question while we're firing this up?
Here we go. So copy paste that. And put that into enter your teacher's username, correct?
Mm-hmm.
Where do I enter that? Let's see.
Yes, I have a question on
Shoot.
the number 5, if the name with the 2 underscores,
Mhm.
that one keeps giving me an X. So is it a space after the if?
Could be. If you don't mind, I can hop into yours if you set me as your instructor
Yeah.
real quick while he's working on that. Are you? Where's your? Here you go. This you right here. Component 63.
Say again, I'm sorry.
Right here.
Oh yeah.
Okay,
Mhm.
cool. Cool. All right. So I'm going to go into your files. All right. So you got 2 files here. I'm going to look in your main.py. It looks like you forgot the dot on this extension on this one.
Okay.
That might be a problem. But I'm going to go to the main.py. Yeah. Okay, cool. So yes, you definitely have this little X right here. When I hover over, it says syntax error, right? So this is the value of the text editor. It's a syntax error. This,
It's those spaces that's getting me every time. Like
yeah.
when you're writing all the different codes, I
Mhm.
think because some words are together and some aren't. So how
Some
do
are
you
not, no.
know when there's
Yeah.
spaces when you're writing things?
Most between them, I'll put it that way. So like if space. So there's definitely missing a space there. This right here is also going to be a problem for you because it's 2 equal signs. So it looks like you hit shift on the second one and made it a plus sign instead. And then this last part, main, should be a string. So it's got to be inside quotation marks. And there should be 2 underscores after it as well.
And a space. 2 equal signs and then a space?
After the second, the colon and the colon, there's no. I think that might break. But
Yeah, it doesn't you can't talk, I can't talk and move at the same time. Isn't that weird? It won't
here, let me get out of this. I don't know if me being in the file might be messing you up. Let me get out of this real fast.
Oh, maybe that's it. It's like,
Yeah,
what?
if you have two instances of it
Okay.
open at the same time. So try fixing.
Okay. I thought it was me talking and it won't let me move it at the same time. I was like, what?
Nah, I think it's probably to prevent conflicts. Let me go back to my version so you can look at it as the example. So you see here, it's got to be if, then a space. Then your 2
Okay,
underscores
if,
for
and
name.
then a space, and then the 2 underscores, and
Yep.
then a space.
Nope, no space. The 2
No
underscores,
space.
name, 2 underscores, that's all one chunk.
Okay, and then the 2 equal signs,
Yep.
no space.
This space actually matter, but I put one in there just because it's convention and it's easier to read.
Okay, and then the main, and then,
Make sure that this is a string. Make sure it's in quotation marks.
oh, that is, see, I thought it was just something on the screen. So
Nope.
that main is
Yep.
in quotation.
It's in quotation
Okay.
marks, a string. Yep.
I
and
see
it's,
that.
and it's got 2 underscores in front and back, just like name. So it's double underscore main, double underscore.
Okay. I didn't see that. I thought,
Yeah. And then
okay,
the
so
main
now it's correct.
All right.
And there's a space after it, or no?
No space between the string
That's
and the colon.
why, so
Yep.
now if I hit run, it should do it.
Make sure you have it indented. When I was looking at that before, you had this, you had print all the way up at the edge. Make sure that there's an indent there. Make sure there's either 4 spaces or 1 tab.
Okay,
And then it should work. Yeah.
and there it is.
You got it?
Amazing, right?
Nice.
Okay.
Nice. Chris, you got
I
me.
gave you permission now, so I think
Cool.
so. I think you're in there.
what is your username?
Frosted Python.
Oh, there you are. Yeah, I was gonna say the one I didn't recognize. All right, cool. So let's go have a look at your file. Main.py. All right. Yes. Wow. Yeah, that's a weird error. That's not super helpful, I don't think. Okay. So looking at this, where do you think you may have gone wrong? Even though the error is not real helpful.
Possibly an indentation on the fourth line, maybe.
Yes. This right here is definitely not what you want. I think this, I think that might be right. But this one definitely is not, because so there's no, this isn't part of a block anywhere, right? And so when it comes to this break here, it's an unexpected break. It's not expecting this indent to be there, so it's just kind of falling apart. So I'd take that out for sure and see if you get it. It's funny it didn't give you an error though. It didn't give you a little red X on the side, because that's definitely a syntax error. But try taking that in and get out of your file so you can make the change. What you want it to look like is, come back to my own files.
I got to get back in there.
So what you want that print statement to be is right up against the edge with no spaces at all. So you can call a print statement here straight up against the edge, outside of a function.
But when I try to go back to where those things were, I'm not there. It's giving me that error code or whatever, and I don't know how to get back to the lines of code.
Oh, so yeah, just open this file again. Go to files and then just open your main.py file, and it should be saved from where it was, and then you can just make changes directly in the file.
Oh, okay, there we go.
And then all you're looking to do is just fix that gap between the print statement and see if that solves your problem. But again, you could just wrap it in this application entry point to get to the end, and then you would need the indentation.
So why isn't there not needed an indentation on that fourth line with print?
This one right here. So this is just calling it. This is calling print, which is a built-in function. You could just do that. So what's going to happen here is it'll just print every single time we call this file, right? So you probably don't want to do that, but it's not going to hurt anything. It's just going to pop up every single time. So if I run this now, it probably should say both of those things. It'll spit out both print statements. So there's this and there's hello world. So it works. It just, and so this is a debugging technique, right? If you have a long, process or algorithm or something like that, and variables are changing throughout, you can print a variable kind of wherever you want to in your code, and it'll execute and print when it calls, whenever you call that function.
Okay,
right?
it works.
Cool.
It worked.
Cool.
Yep.
Excellent. All right. Anyone else?
Now I just need to go back in and do that third line.
Yeah, get this little app entry point in there. I'll leave that open so you copy it down. Anybody else stuck? Got questions? Once again, this is the checkpoint for today. So I want to make sure everyone gets this piece down and is able to then go and play with these things and mess around with it a little bit between now and next time.
Jeff, rather than just go into the references and start reading, do you have a set of practices you would like us to focus on for Monday or Tuesday?
Yeah, I love it. Just like you're reading my mind, man. I was just about to hop over and end with exactly that. Yeah, for sure. It's like we're in the same headspace. So in the free coding resources, there's all kinds of great stuff in there. Honestly, if you just took this, you could dive in for hours. I've highlighted some things that are going to be really, really helpful. The first one that I really encourage everyone to look at is this Legacy Python for Everybody course on Free Code Camp. It's broken down all things on Free Code Camp. If you haven't checked it out, this place is amazing. It was one of my favorites, one of the first things I started using. They're all broken down into these really small courses of a few minutes long. There's maybe like a little challenge at the end of it. The guy that does this is an old Dr. Charles Severance, University of Michigan School of Information. He explains Python way better than I ever could. at these basic levels, right? So Python is a language, the elements of it, variables, expressions, things that we're not going to cover in this class that are very good to know about Python. I would recommend, if you got some time and you want to dig into those sorts of things, that's a good place to start. If you're already a little more familiar with it, maybe one of the scientific computing for Python. If you want to go all full on the web development, those have those too. But I would recommend starting with that Legacy Python for Everybody course. And again, use the things that we built already. Use that framework and play with it and break it, figure out what it does, experiment with it. If you have questions about the style of things, look at the pep page. So those two things I think would be plenty to do between now and Tuesday. If you want to work ahead, what we're going to do on Tuesdays, we're going to talk about the conditional control structure if a little bit further, go all the way in with the other conditions you can add to it. We'll talk about while loops, and we'll talk about classes. So if you want to read up on those things, there's some good reading down here about Python in general, like Automate the Boring Stuff. I know somebody already started kind of reading that. That's a good book about Python. It has some things in there. And then next week, it's going to be relevant when we start talking about algorithmic problem solving. We're going to have problem sets on Tuesday that I'm going to send out. This section, the exercises gently explained, is talking about how to do those and how to approach those. So any of those readings, if you prefer doing the online self-paced training, those will all be valuable before next time. Cool. Anyone else? Any other questions, comments, or needs? Anything else? All right. So we are right at time. We can wrap up for today. Open invitation for everyone. If you are working on this over the weekend, tomorrow, Monday, between now and next class, and you have questions, reach out on Discord, reach out to me, set up some time. We can go through one-on-one. We can look at what you got, whatever you need. So if nothing else, I will see you Tuesday.
Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you.
Thanks, Jeff. Have a good night.
Yep, you too.
Thank you guys. Good night.
Thanks a lot, y'all.
Hey, Jeff.
Yep.
I think it's going to help me. I've got to go and get my desktop. I'm working on a laptop right now,
Okay.
and I'm just not used to. I'm used to having multiple monitors, and a good enough system where I could go back and forth and
I get
not
you.
miss anything like that, because this it's kind of slow on this laptop, and so I'm not able to keep open the things that I need to keep open to follow right
Okay.
along. So yeah.
All right. Yeah.
But all right, we'll look forward to seeing you next Tuesday.
Yes. Yes. Have a great weekend.
Take care.
See you later.
So the recording's usually like gonna be an email like an hour later.
Yeah, whenever Zoom process, it takes an hour or two. And I'll email it, and I'll also pin it in Discord and put it up in there. So if you prefer getting it that way, that's way. I always send it out an email anyway, just because some people never get on Discord, But all the videos, all the documentation, everything like that will be in Discord.
All right,
Too.
appreciate it. Thank you.
Yep, for sure. Take it easy.